Hello, welcome to Pre-Cal Lecture 1.12, where we're going to talk about complex numbers. So section 1.12.1, we're just going to introduce you to complex numbers. So let's say we have the square root of -9. So no number multiplied by itself will give you -9. All right, but however, it can be useful to be able to take the square root of a negative number. All right, so a lot of times a negative sign in science or engineering represents direction. Okay, so you may be able to need to take the square root of a negative number because that number indicates direction. So you'll see in physics and electrical engineering, disciplines like that, it's really useful to be able to use complex numbers. So for the square root of -9, let's rewrite that as the square root of -1 times 9. So that would be the same as the square root of -1 times the square root of 9. So that's going to be 3 times the square root of -1. The square root of -1 we call I. Okay, so I is equal to the square root of -1, which is a complex, not imaginary, a complex number. So, for example, if you had 3 times the square root of -1, we would write that as 3i. Okay, so a complex number the way that we write that is a real number plus or minus a real number times I. All right, so for example, 2 plus the square root of -9, we would just write that as 2 plus 3i. Or 3 plus the square root of -25, we would write that as 3 plus 5i. So this is the real part, and this is the complex part. All right, so that's explaining the basics of it. Now let's get into some example problems. Okay, so section 1.12.2, we're going to be rewriting powers of I. Okay, so let's start out with I. That equals the square root of -1. And I want you to write this over to the side because this is a little shortcut I'm going to teach you. I want you to write just 0.25. Now that's not equal to 0.25, but 0.25 is going to be, I'll go ahead and label this our calculator shortcut. Okay, let's say we have I squared. That's equal to the square root of -1 times the square root of -1, which is just going to be, if you multiply a radical times a radical, the radical lifts, and you would just get -1. All right, so I'm going to move this part over. I didn't leave myself enough room, so way over here we'll write 0.25. And I want you to write way over here 0.5. And again, I'm not saying that -1 is equal to 0.5, all right? You'll figure that out in a minute. Let's say we have I cubed. Well, that's going to be I squared times I, right? Which would be -1 times I, which is -I. So I cubed is the same as -I. And the number that I'm going to have you memorize for our shortcut is 0.75. And then I to the fourth would be I squared times I squared, which is going to be -1 times -1, which would just be 1. So I to the fourth is just 1. And that's just going to be 0.0 or in your calculator or even. So I'm talking about what I'm talking about here is the decimal on your calculator, and I'm going to explain that in just a second. So let's keep going. What's I to the fifth? Well, that's going to be I to the fourth times I. And that's going to be 1 times I, which is just equal to I. So you see I to the fifth is the same as I. Okay, and then I to the sixth is I to the fourth times I squared. Well, that's going to be 1 times I squared, which is just going to be, we know I squared is -1. So see how the process just repeats once you get to the I to the fifth is the same as I to the sixth is the same as I squared. I to the seventh would be the same as I cubed. We have a repeats every 4 exponents. So the cycle repeats. Okay. So I'm going to show you how you can figure out if you're given I to a power, how you can figure out with your calculator which one of these 4 it is. Okay, so let's do an example where we want to know what I to the 40th is equal to. So what I want you to do, okay, so here I'm going to put this, and hopefully you can see it. I want you to take 40, that's the exponent, divide that by 4, and see how it's 10. So it's even. It doesn't have an exponent. So 40 over 4, the decimal is even. Well, which one of these matches that? Well, that's the same as I to the fourth. which is just equal to 1. So I to the 40th is just another way of saying 1. All right, we're going to do a couple more, and then hopefully you'll get the gist of it. So let's say we have I to the 223rd power. Goodness, you would hate to just keep going down the list again and again and again and again, right? So what I want you to do is take that 223, divide it by 4, and then let's see what the decimal is. Okay, so 223 divided by 4, the decimal is 0.75. So we don't care about the 55, it's 0.75. So which one corresponds to 0.75? It's I cubed. And we know that I cubed, and you do have to memorize all of this, is just negative I. So I to the 223rd is just a fancy way of saying I cubed, which is negative I. All right, let's do one more. Let's say we want to figure out the reduced version of I to the 2001. So you're going to take the decimal, you're going to take the exponent, divide it by 4. So 2001, A Space Odyssey, divided by 4 is 500.25. Don't care about the 500, only the 0.25. Well, 0.25 corresponds to I. All right, and there's really nothing more you can do with that. It is I. So I to the 2001 is just I. So that's your shortcut, so you're not having to go through the cycle in your head again and again and again. Just memorize what I squared, I cubed, and I to the 4th is, which is, I is just I. I squared is negative 1, I cubed is negative I to the 4th is 1. And then memorize that we start at 0.25, then 0.5, then 0.75, and then even. You'd get an even number if it's I to the 4th when you divide the exponent by 4. Okay, so that's kind of a cheat code there on trying to figure out what a particular exponent, where in the cycle it is. And I'm sure there's other ways to do it, but I have found that my students have just preferred to it's pretty easy to memorize. My students have preferred to memorize it. Okay, 1.12.3 is adding and subtracting. Complex numbers. And this is super easy. I'm just going to go straight to an example. So let's say we have, and I'll put them in parentheses just to make things a little easier. 5 minus I plus 9 minus 2I. All you have to do is add the real part and the complex part separately. So we're going to add the real part and then we're going to add the complex part and just report what we get. And that's all it is to it. So 5 plus 9 is 14. Negative I plus negative 2I would be negative 3I, so 14 minus 3I. My goodness, please don't miss that on the test. You will be mad at yourself. And the next example, let's say we have 7 minus 3I minus negative 5 minus I. So we'd have 7 minus 7 plus 5 would be 12. And then negative 3 minus negative I would be negative 3 plus I, so minus 2I. So you won't mess this up unless you mess up, subtracting a negative or something like that. All right, 1.12.4 is multiplying complex numbers. Okay, so we just need to remember that I squared is equal to -1. If you can remember that, then you're going to be pretty good with these. So, a couple of examples here. Let's say we have 2 plus 3i, and we're going to multiply that by 6 minus 5i. So all we're just going to do here is FOIL it. So I'd have 2 times 6 is 12, and then I have 2 times -5, so minus 10i. That's the outside. The inside would be plus 18i, 3i times 6. And then the last one is 3i times -5i, so that would be minus 15i squared. Okay, so this is going to be 12. -10 plus 18 would be plus 8i. And then minus 15, and remember I squared is -1, so times -1. Well, that's going to be 12 plus 15, right? So that would be 27. So the real number goes first, plus 8i. Make sure to do the real number first. All right, and another quick example. Let's say we want to expand 3 plus 5i all squared. So that's going to be 3 plus 5i times 3 plus 5i. It's going to be 3 times 3 is 9. Plus 15i plus another 15i, so that's plus 30i. So I just did the inside and the outside all at once, and then plus 25i squared for the last. That's going to be 9 plus 30i plus 25 times -1. Well, 9 minus 25 would be -16, right? We need to write that first. So -16 plus 30i. So please don't miss that on the test either. It's easy peasy. The only reason you would miss it probably is you just made a mathematical mistake. So double check, because you don't want to miss those. All right, we've got one more section. I may need to get me a new marker. We'll see here. So let's do 1.12.5. Yeah, that one is smushed. Sometimes these new markers take a minute to get dark, but dividing complex numbers. Okay, so what we're going to be doing here really is just rationalizing. So let's say we have 4 plus I over 3 plus 5i. That's the same as 4 plus the square root of -1 over 3 plus 5 times the square root of -1. And remember, a radical in the denominator is bad form. So how do we get rid of the radical in the denominator? We multiply by the conjugate of the denominator over the conjugate of the denominator, a clever version of 1. So let's rewrite it in terms of I. And we're going to multiply that by the conjugate of the denominator. So that would be 3 minus 5i over 3 minus 5i. And now we're just foiling. So 4 times 3 is 12. And then we have 4 times -5i, so minus 20i. The inside terms would be plus 3i. And then I times negative 5i would be minus 5i squared. Then on the bottom, we're going to have those middle terms go away. So 3 times 3 is 9. And then we would have minus 15i and then plus 15i. That was the whole point of rationalizing, right? And then minus 25i squared. So this part goes away, and that's your radical, your square root of negative 1. So I'm going to do some combining here. In the numerator, we would have 12 minus 17i if I combine the I terms, and then minus 5 times negative 1 over 9 minus 25 times negative 1. So replacing the I squared with a negative 1. That's going to be 12 plus 5. So on top we'd have 17 minus 17i. And on the bottom, 9 plus 25 with the two negatives, 34. All right, that's great, but 17 will go into 34 two times. So I can reduce this down to 1 minus I over 2. So I want you to do that. So you have a 1 and a 2 and a 1 there. All right, so that's the best way to write it. You could write it as 1/2 minus I over 2, something like that. This is the best way to write it. Okay, so let's do one more. Let's say we have 6 plus I over I. You're thinking, okay, well, what is the conjugate of I? Well, you could do negative I. That is totally fine. That will work, but there's a simpler thing to multiply by. How about I over I? That way I don't introduce a negative term, but I get rid of the I, because what we would have on top is 6I plus I squared over I squared. So that's going to be 6I, and then I squared is negative 1, so minus 1 over minus 1. So if I divide minus 1 into both terms, I would have negative 6I plus 1. And remember, we want the real part first. So that's 1 minus 6I. That's how I want you to report it. I don't want to have to count off anything because you put the I term first. I wouldn't count off much, but you don't want, it's kind of like a unit. You don't want to lose a point because of that. So the homework is the whole worksheet. 1.12, and there's 13 of those. Let's look at it real close. So we're going to rewrite as a complex number. That was kind of the beginning of your notes, and then this is where you use your calculator to figure out where in the series it is. And just let me give you a hint on something to a negative exponent. So if I have a negative I to the negative 13, remember that's the same as 1 over negative I to the positive 13. So that would probably be easier for you to think about that by making the exponent positive by moving all of this into the denominator. So you have a couple of those, actually 3 of them. Let's see. These are hard to read. I wrote them really small. So that's I to the 42nd, I to the 31st, I to the negative 42, negative 28, and negative 13. So there's a little negative sign. I apologize for the small font. All right, this is just adding and subtracting real and complex numbers. That's easy peasy. This multiplication here, you do some foiling. This last one is a little bit tricky because I put an extra I out there. Just distribute that I last. Foil first, then distribute the I last. And then we're going to simplify these by multiplying by the conjugate and reducing it down. So I think the homework is a lot like the notes. So hopefully you will be able to have pretty good success on that. And I will talk to you on the next one.